My intent with this video is to show you, visually, just how huge the universe is, and also touch on what we can learn from that. Stick with me, because however big you think the universe is, it's bigger. Much, much bigger. The observable universe, just the part we can see, is 93 billion light years in diameter. Now, when I say 93 billion light years in diameter, that doesn't really mean much. We know it's big, but we can't really conceptualize a number that large. Large numbers are difficult to visualize, so let's start with something we all know. Earth, and then we'll work our way up from there. Our pale blue dot is bigger than most people give it credit for. If you could drive around the entire Earth at 60 miles per hour, it would take just over 17 days to go around it. Or if you were to fly around it in a standard airliner, it would take you just over 2 days. So yeah, this rocky dirt ball we call Earth is pretty big. It's taken humanity thousands of years to traverse the globe, to develop it, and to map it all out. And those are all pretty recent accomplishments in the grand scheme of things. Zooming out from Earth, we'll eventually see the moon. Now, we've all seen pictures like this in the upper left corner, and it makes it seem like the Earth and moon are pretty close. But as the moon comes in from the right, it becomes apparent that they are very far apart. The moon is 238,000 miles away. Even a number this small is hard to conceptualize, at least for me it is. We all understand the speed of a car, so we'll use that to show just how far away the moon is. Now imagine getting in your car and driving at 60 miles an hour for 6 months. No sleeping or bathroom breaks either. That's how long it would take to drive to the moon. This moon, this satellite that orbits the Earth, is the furthest humans have made it into space. 12 people have walked on the moon, and that's an amazing feat, but really not very far when you consider what else is out there. We have some probes and robots that have made it further, but this is the furthest we as a species have made it. We really are at the infancy stage of space exploration. As we move out, you'll see the orbits of other planets turn on. Now, we've all seen graphics of the solar system that show the planets to be quite large and close together. Obviously, this is done for practical purposes, otherwise we wouldn't be able to see any detail. The problem though, just as is done with the Earth and the moon in many cases, is people assume that's what it's really like out there. This really gives a false impression of the immense size of the solar system. If you were to look at the solar system to scale from this distance, this is what you would see. Nothing. The planets are so small and the space so big, you literally wouldn't see anything. That's how small they are in comparison to the vastness of our solar system. Speaking of the planets, here's a true scale of the planets compared to each other. There is Earth, and there is our Sun, which you could fit 1 million Earths inside of. The average distance between the Earth and Sun is 93 million miles. This distance is referred to as an astronomical unit. How far is that if it were a road trip? It would take 177 years to drive to the Sun, and if you're in a hurry, you could get there in about 19 years via commercial airliner. What about driving to Neptune? How long would that take? It would take 5,000 years by car and 600 years by plane. So yeah, the solar system is immense, and I want to give you one more visual to really drive home how big the space is between the planets. Let's shrink the solar system down to the size of a football field. At this scale, our Sun is just over 1 inch in diameter and sitting on the goal line. The inner planets, Mercury, Venus, Earth, and Mars, are smaller than the ball in a ball-tip pen, and they're all within the first few yards. The outer planets, or the gas giants, would be smaller than BB pellets and way further down the field. The solar system is huge, and it's easy to see why we haven't made it very far. There's a lot of empty space out there. Hope is not lost though. We've sent several probes and robots into space, and they can go much faster than a car or plane. Our furthest probe, Voyager 1, which you're seeing the path of here as an orange line, was launched in 1977 and has been traveling for over 42 years. It's going about 38,000 miles an hour and is now over 13 billion miles away. It's the most distant man-made object in space. It passed all the other planets' orbits back in the 80s and it's still going. Voyager 1's official departure from the solar system occurred in August 2012. As we zoom out, you may be wondering where the boundary of our solar system is. Great question and a bit tricky to answer. Some define the edge of the solar system using Neptune's orbit, which is 5.6 billion miles in diameter. Some use Pluto's orbit, others use the heliosphere, and some others define the border of the solar system at the outer limits of the Oort cloud. That's the orange sphere you see here. The Oort cloud is made up of billions of comets, basically dirt ice balls, and they orbit the Sun way beyond the orbit of Neptune. So there are several ways to define the edge of the solar system. In one, where Neptune is the outer boundary, it takes light 4 hours to go from the sun to the edge of the solar system. In the other scenario, with the Oort cloud, it takes light over a year and a half to go from the sun to the edge of the solar system. That's over 3,000 times larger than Neptune's orbit, so quite a big difference between them. For the sake of simplicity, I'll be using Neptune as the boundary of the solar system. I mentioned a light year, so let's touch on that briefly. A light year is the distance that light travels in a year. Light travels at 186,000 miles per second. Here are the Earth and Moon to scale. It takes light 1.3 seconds to get from the Earth to the Moon. It would take you 6 months to drive that far, and light is traveling that far in 1.3 seconds. That's fast. It's going 186,000 miles per second, 11 million miles every minute, 670 million miles every hour, 16 billion miles every day, and just about 6 trillion miles every year. Everything is so far away in space, and we don't want to have to write down these huge numbers, so we use the term light year to make it easier on us. In terms of light speed, we're just 8 minutes from the sun. That's how long it takes light to travel from the sun to the Earth, and Neptune is 4 hours away, in terms of light speed. If I haven't said it enough, let me say it one more time. The solar system is really big, which is really why we haven't made it too far just yet. But when you compare our solar system to the Milky Way, it's just ridiculously small. As we zoom out in our journey, you'll see the nearest star to us, Proxima Centauri. It's about 4.2 light years from the Earth. That's 25 trillion miles. Great, huge numbers again. Let's simplify it a little. If you scale down our solar system to the size of a quarter, how many quarters, or how many of our solar systems, could you fit between us and the nearest star? Go ahead, give it a guess. 1, 5, 10? You could fit 4,450 of our solar systems between us and the nearest star. At this scale, the nearest star is 350 feet away from our little quarter-sized solar system. Just to humor you, it would take 47 million years to drive there, or 5 million by plane if you're in a hurry. Now, if you're going the speed of a space probe like Voyager 1, which is traveling at 38,000 miles per hour, it would take about 73,000 years to travel to the nearest star, 4.2 light years away. Which isn't too bad, but it's still over 2,500 generations. So obviously we're not getting there until our technology improves. There's Sirius, the brightest star in the night sky. It's about 8 light years away. Here's our little neck of the woods, about 16 light years from Earth. There are 52 star systems within its area, but we can't see all of them because some of them are quite dim. But you can see other far off stars. There's Betelgeuse off in the distance some 645 light years away. That star is 1,000 times larger than our sun. That's our interstellar neighborhood, about 50 light years across. With our current technology going the speed of Voyager, it would take almost 1 million years to travel across this region in space. Zooming out a bit more, just beyond our interstellar neighborhood, we get to the radiosphere. This sphere represents the extent of all human broadcasts since about the time of World War II, when we became radio bright as a species. At about 160 light years across, this area is filled with approximately 3,000 to 5,000 stars. Again, not all are pictured here because only the brightest stars can actually be seen from this distance. By the way, you're seeing real data here, real stars and their locations from a program called OpenSpace. This is the digital universe, and if you're interested in exploring it yourself, please go check them out. I'll link to their website below. It's completely free as well. As we get close to 1,000 light years away, which is just 1% the diameter of the Milky Way, it becomes apparent that the Milky Way is larger than we can even imagine. There are at least 100 billion stars in the Milky Way. That's 100,000 millions. But big numbers kind of go in one ear and out the other. When we hear the term a billion, we don't visualize it. We simply can't. We just say, yeah, a billion, that's like a lot. It doesn't quite register. So let's take a second to talk about big numbers. To count to 1,000 would take 17 minutes. To count to 1 million would take 12 days. And to count to 1 billion would take 32 years. If that doesn't do it for you, let's try visually. Here are 100 stars. 100 of those is 10,000. 100 of those is 1 million. 1 million is a lot, right? But believe it or not, it's not much compared to a billion. It's just 1/1000th. Here is 100 million. Here is 1 billion, and keep in mind that each small block is 1 million. And finally, 100 billion. Okay, one last example. We'll use distance this time. If 15 feet were to represent 1,000, then 1 million would be 3 miles. And 1 billion would be from Cape Canaveral to Seattle. Oh, and a trillion? That would be 12 times further than from here to the moon. I just want to stress this point so we can really appreciate what a huge number 100 billion is before we get deeper into this, because the universe is about to get a whole lot bigger. Let's zoom out to the entire galaxy, full of billions of stars. Remember that blue sphere that was 160 light years wide? That's it. That's the speed of light radiating from our planet in the form of radio waves for the last 80 years or so. We haven't even made a dent. Some astronomers even believe there are as many as 400 billion stars in our galaxy alone. That's absolutely mind-numbing. The Milky Way is home to hundreds of billions of stars, each one potentially having its own planets and possibly its own life forms. In the last 20 to 30 years, we've studied very small sections in the Milky Way and discovered that other stars have planets too. Based on this data, scientists now believe that most of the stars in our Milky Way actually have a family of planets orbiting them. By extrapolating this data, that means there are billions of other planets out there in our Milky Way alone. The Milky Way is about 120,000 light years across and 1,000 light years thick on average. Alright, if that doesn't make much sense, let's forget huge numbers for a second. Let's use another comparison to bring things down to a scale we can relate to. Let's go back to our solar system being shrunk down to the size of a quarter. If our entire solar system was the size of a quarter, our Milky Way galaxy would be about the size of North America. I can't even find a quarter in my own couch, and if you said to find one particular quarter in North America, it would be pretty much impossible. Trying to see our solar system at this scale would be like trying to see a quarter from space. Now, our sun is just one of hundreds of billions of stars in our Milky Way. So imagine all of North America covered with billions of quarters. The quarters representing star systems like ours. At the center of each quarter is a tiny speck, smaller than a speck of dust, that represents a star. At this scale, our nearest star, Proxima Centauri, as mentioned earlier, is 350 feet away. So imagine, if you will, quarters scattered all over the place, every few hundred feet, all over North America. That's pretty incredible. Here you can see the orbit of our sun around the galaxy. Even though the sun is traveling around the galaxy at over 500,000 miles per hour, it still takes 225 million years to complete one revolution. If you're still not impressed with the sheer magnitude of space, let's move past our galaxy. Let's get serious. The Andromeda Galaxy is about 2.5 million light years away. Zooming out even further to about 110 million light years, we see the Virgo Supercluster. There are thousands of galaxies here, similar to ours, with hundreds of billions of stars and planets. As we continue to zoom out, we see other superclusters that have been mapped out. The dark region is called the zone of galactic obscuration because it is obscured by our own Milky Way. And finally, quasars come into the picture. As we move past the cosmic background radiation left from the Big Bang, we see the entire observable universe. 93 billion light years across. We may never know what's beyond the part of the universe that we can see, but due to the acceleration of space, it is believed that the universe itself is at least 250 times bigger than the observable universe. Wow, a lot of information, but what's the point? What can we learn from all of this? First, can we all be honest with ourselves for a minute? The truth is, we know nothing. Pretending we have all the answers limits our open-mindedness to what's really out there. Look at us floating around on our little dirt rock ball in the middle of nowhere. It's great that we're able to see as deep and as far as we can into the universe, but ultimately, we know nothing. We don't know why things happen the way they do. More than likely, whatever it is that is happening for reasons that our little brains simply can't comprehend. So the next time something happens that doesn't go your way, just go with it, man. Just go with the flow. Do you really think there's any point in resisting the universe? Also, we don't have to know everything. Accept that we don't have all the answers and enjoy life. Live the moment you're in, do things you're passionate about, and just have a good time while you're here. Second, you are the universe. Eckhart Tolle stated, "You are not in the universe, you are the universe, an intrinsic part of it. Ultimately, you are not a person, but a focal point where the universe is becoming conscious of itself." What an amazing miracle. Obviously, from our limited perspective at this moment, being in our heads, we feel quite separate from the universe. But think about this. Every atom inside your body was once in a star. When a star explodes, it sends new materials and elements all over the place. And that's where carbon, metals, and everything else comes from. That in turn forms other stars and the planets ultimately create you. That's how you were made, literally from star stuff. It took billions of years for the universe to evolve and change and create us. We're tiny, but we're also exceptionally special, as is everything in the cosmos. Here's my belief. The universe is intelligent. It's not just a bunch of dumb matter floating around colliding haphazardly. One universal intelligence, or one consciousness, is what's guiding this whole thing, including you. We just feel like separate selves because that's how our limited minds work. You didn't come into the universe as some separate thing. You came out of the universe. You were born from it. Ultimately, you're not some separate thing. You're the whole thing, which means we're all in this together. As Neil deGrasse Tyson puts it, we're all connected. To each other biologically, to the earth chemically, to the rest of the universe atomically. Not only are we in the universe is in us. So do your best to treat everyone with love, respect, and dignity. We need to stick together as a species and a planet if we're going to survive. And I think we will. I'll leave you with one final quote. The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. Carl Sagan. If you stuck around for this entire video, thank you. I hope you enjoyed it. Please like and subscribe if you can. And please drop me a comment and let me know what you think we can learn from the enormity of the universe. I would love to see what you all think. Thanks, and I'll see you next time.